Okay, so we're going to talk about higher powers of I today. Well, we know I to the first is just I. I to the second is I times I, which we know is -1. I to the third is I times I times I. Well, I times I is -1, and then we're left with -1 times I, which is -I. And then we have I to the fourth. Well, I to the fourth is I times I times I times I. Well, every I times I is a -1. So we have -1 times another -1, which gives us 1 whole. You want to memorize these.
You want us to memorize like the pattern, or like do you want us to memorize?
No, I want you to know that I to the third is -I. Yep. Okay, well, what happens when we go higher than I to the fourth? Let's see. If we are I to the fifth power, well, isn't that I times I times I times I times I? But every 4 I's multiplied together is what? 1. So this just leaves us with 1 times I to the first, which is just I. What happens if we have I to the seventh power? Well, that's I times I times I times I times I times I. Did I make too many I's? No, I'm good. All right, so we know every 4 I's multiplied together is 1. So that leaves us with 1 times I to the third, but we should memorize this. What's I to the third? -I. Do we see a pattern here? Do we see a pattern here?
Yes.
No? Yes? No? Maybe so? Okay, what about I to the sixth? I to the sixth is 6 I's multiplied together. And then we look for a group of 4. Oh, I made too many I's. One too many I's. So then this is 1 times I squared, which is -1.
I see it.
What are we doing?
Taking out the 4.
Good, we're trying to find groups of 4, but what happens when we go really much higher than this? So let's say I said I to the 25th power. What do you think I'm going to recommend we do? Philip?
Well, I to the 25th is I to the 24th times I to the first, and I to the 24th, since it divides by 4, is 1, and then I to the first is I, so that'll be just 1 times I, which is just I.
Exactly. Philip explained the process perfectly. What you want to do is you want to change this into a multiple of 4. Why are we changing it into a multiple of 4? Because we know every group of 4 I's is 1. So when we change this to the closest multiple of 4 without going over, we're going to change this to I to the 24th times I to the first. And we know I to the 24th has to be 1 since it's a multiple of 4. So this brings us to 1 times I, which is just I. Okay, what about if I had you do this? I to the 27th power. Right, again, we're going to change it into a multiple of 4. So we're going to change this into I to the 24th times I to the what? Third. Every multiple of 4 becomes just 1. So then we have I to the third, but we should have memorized this. What's I to the third? -I. All right, you guys do this one. I to the 46th power. Shh, guys, too much.
Come on, James. You lost your temper. You're spoiling it.
What did you all get?
-1.
-1. We get the gist?
Yep.
Good. All right, let's move on. Now my directions are to simplify. So I have 1 over 2i plus 1 over 3i squared plus 1 over 4i cubed. Can I eliminate the denominator here? Can I eliminate? No, why not? It is not an equation. So in order to simplify this, I cannot eliminate the denominator. I must create a common denominator. But before I'm allowed to create a common denominator, what do you think I'm going to tell you to do? We're going to simplify the denominators because don't we see i's to certain powers that we can simplify? And then after we simplify, I'm going to recommend we rationalize. So let's simplify, then rationalize, then create a common denominator. So we have 1 over 2i plus, isn't 3i squared just -1, so this makes it -3? And then we know I cubed is -i, so this becomes a -4i. Now, before I create a common denominator, I want to rationalize. So for the first fraction, I'm going to multiply by I, numerator and denominator, which will give us I over -2. The second fraction is fine. For the third fraction, I'm going to again multiply by I, numerator and denominator, and we're going to get I over 4. Yes.
What happened to the negative in the second fraction?
Oh, that needs to be there. Thank you. All right, now I'm going to create a common denominator. I'm going to actually assign the negatives to the numerators. So this is going to be -i over 2 minus 1 over 3 plus I over 4. I just brought the negatives to the numerators instead of the denominators. So now when I create a common denominator, my common denominator will be 12. So for the first fraction, I'm going to multiply top and bottom by 6. The second one, I'll multiply numerator and denominator by 4. And the third one will multiply numerator and denominator by 3. So then we end up with a -6i, 4, and 3i. And now we can simplify that numerator, and I will get a -4 minus 3i all over 12. There's nothing to pull out to simplify, so we leave our answer just like this. Can I distribute in that exponent? Yeah, how come this time I can, but a lot of times I tell you we can't? Good, because this is a monomial. So what does this become? This becomes I to the 4th times the root root of 3 to the 4th, square root of 3 to the 4th. Well, we should have this memorized. What's I to the 4th power? 1. And then, isn't this 3 to the half raised to the 4th? Right? So we can power to a power, multiply, so we end up with 3 to the 2nd, which is 9. Okay, I want you guys to do this one by yourself. 1 plus I squared. Can you distribute that? No, you have to multiply it out. Because it's a binomial, you have to multiply it out. What'd you all get?
2i. 2i.
2i.
Yes, 2i. 1 plus 2i.
No 1. No 1 plus 2i. Do you want to see it, Kai?
Oh, I thought 1 times 1 was 2. I fixed my problem.
Okay. So, should we have all gotten 2i? I want you to remember this, that 1 plus I squared is 2i. Why? Why do I want you to remember this? It will make some problems easier. Let me show you. So in the next problem, I'm going to have 1 plus I raised to the 6th power. Now, because it's a binomial, you absolutely cannot distribute that exponent of 6. So you might be thinking, okay, well, I have to multiply 1 plus I 6 times. Multiply it times itself 6 times. That's a lot, right? Or you can remember that 1 plus I to the 2nd power brings us down to a monomial, which is a lot easier to multiply monomials versus binomials. So how can I manipulate this without really changing its value? I can change this into 1 plus I raised to the 2nd raised to the 3rd. Why did I do that? Well, if we remember that 1 plus I to the 2nd is a monomial, what's the monomial? 2i, then I'm going to have 2i raised to the 3rd, and can I distribute that exponent? Yeah, because it's a monomial. So this is going to give us 8i cubed, which is just negative 8i. See how much easier that problem became just by knowing that 1 plus I squared is a monomial? Okay, next one. I want us to show that 1 plus I is a 4th root of negative 4. Okay, forget all this i's. Do we all agree that 2 is a 3rd root of 8? Yeah, what does that mean when I say 2 is a 3rd root of 8? It means that 2 times 2 times 2 is 8, right? 2 is a 3rd root of 8, so 2 times itself 3 times gives us that 8. So when it says show that 1 plus I is a 4th root of negative 4, what is that suggesting? That if I were to take 1 plus I and multiply it times itself how many times? 4 times. What should that equal? Negative 4. So in order to show it, we are going to take 1 plus I raise it to the 4th power, and we need to show the person reading this, which will be me, that that is -4. Do you think I'm going to multiply this out 4 times? No, what can we do?
2y squared.
You got it. We can change this into 1 plus I raised to the 2nd raised to the 2nd. And we know 1 plus I is 2I. So if we take that 2I and raise it to the 2nd, let's see what we get. So we're going to get 4I squared, which is -4. Did we show that it was a 4th root? Yes. All right, now the next section, I'm going to ask us to solve for x. Is this a factoring type of problem? It's not. How come I know it's not? Just by looking at it. Okay.
There are only 2 terms.
There's 3 terms.
Well, like, nothing is raised to us.
Good. There's not one exponent that's double the other exponent. So even though we both have x's here, this is x to the 1st and this is x to the 1st. If this were x to the 1st and this were x to the half, then could we maybe potentially try to treat it like a factoring? Yeah, but is that the scenario? No. For a factoring type of problem, one exponent needs to be double the other. This is not the scenario. This is just a solve problem. We need to solve for x. And when we solve for x, we need to isolate the x. We need to get x by itself and everything else to the other side. So that's what I'm going to do. I'm first going to bring that 4 over. And then we're going to be left with x plus 2ix equals 4. So everything with an x to the left, everything that doesn't have an x to the right. What do you think I'm going to tell you to do now on that left side? Danny? You got it. Pull out a GCF of x. And that will leave us with 1 plus 2i. Now I've managed to get it down to just 1x, and I'm going to solve. So we're going to divide by 1 plus 2i on both sides. Can I leave my answer like this? No, we need to rationalize, so we will multiply by its conjugate. So in our denominator, we're going to get an a squared, which is 1, plus a b squared, which is 4. And in my numerator, because nothing will be able to simplify, I'm just going to distribute it in. So we're 4 minus 8i. So x will equal 4 minus 8i over 5. All right, next one. Is this a factoring type of problem? Yeah, why? Why can we treat this like a factoring problem? We have the same variable, same base, and isn't one exponent double the other one? Or one is half of the other one? Right, so we have an x squared and an x and then a constant. We can absolutely factor this. So we need factors of 6 that add to 5i. Well, the only way to add to 5i is if both factors have an I in it. Do we agree? All right, well, now that's going to change things for us because I times I, isn't that -1? So now we need -1 times what number will give us +6? -1 times -6. That -6, factors of it, that needs to be our coefficients for the i's. So I need to think of numbers that multiply to -6, but add to a +5. So what are two numbers that multiply to -6 but add to a +5? Philip?
6 and -1.
You got it, 6 and -1. Let's check this out. So if I have 6i times -i, that gives me -6i squared. Isn't that 6? So that works out. Now let's check the middle term. 6i minus I, is that a +5i? Yes. So we have our winners. So now we make our double set of parentheses, x plus 6i and x minus I equals 0. But my directions for this were to solve for x. So now we solve. We set each parenthesis equal to 0. And we end up with x equals -6i and x equals +i. Those are our two answers. But you guys try this one.
I don't know if this is a stupid question, but if you put like an I squared in both of the parentheses instead of just an I, and you got it to a 1, would that work? So you wouldn't have to worry about the negative.
So you did x plus 6i squared.
I mean, if you were to put, is there a way to like put an I squared in both of them so you end up with like a +1, and you could just like factor the rest like normal? But that would get rid of the I in the middle term.
Yeah, it wouldn't work.
Do we have to check?
Nope, you only have to check when there is a radical, like when it's a radical equation, or what's the other scenario? Variables in the denominator. Those are the times you check. Okay, next one. You guys try this one. And when I say radicals in the equation, I mean radicals with variables underneath of them. Because like I is a radical, but it's a radical we know. All right, so for number 3, can I change that middle term into 2ix if we wanted to? Sure, if that makes it look better for you, then you can do that.
Get the same one, get iced tea, I'll get a steamer. Get the great.
All right, we ready? So you tell me, what did you get when you solved? X is equal to? Only 2 people? 3 people? That's it? 4 people? 5 people?
I got I and
Negative 3i and I. You got it. Who wants to see me do this? No? We're good? All right, are we ready for the intimidating looking one? Last problem for today. It looks intimidating, but it's not that bad.
Will we get the test back?
Oh, yes, I didn't give it back to you. I'll give it back after this problem. Okay, are we ready? We're solving for x still. We're solving for x. So, what is something I hope you recognize? I hope you recognize that this is some quantity raised to the first power, and that this is the same quantity raised to the half power. What does that mean?
You can like factor like a chunk.
Yeah, we can try to treat this like a factorable problem. We could try to factor it. I'm definitely not going to leave it like this. I'm going to use substitution. So I'm going to let m equal x over x minus 1, that quantity raised to the half. So if m is that quantity raised to the half, then m squared is that quantity raised to the first. Do we all agree with that? So now when we use substitution, we're going to have m squared minus 5m equals 6. Doesn't look so intimidating anymore, does it? So I'm going to factor this. So I'm going to bring that 6 over. M squared minus 5m minus 6 is equal to 0. Let's factor. We're going to have m minus 6, m plus 1, and we will now get m equals 6, m equals negative 1. Are these my answers? No, this is the painful part. Actually, it's not even that painful. The check is the most painful. Now let's plug back in. So we're going to say m is the square root of x over x plus 1 equals 6, and the square root of x over x plus 1 equals negative 1. All right, let's go to the left side. We're going to solve for x. Do we all agree we're going to square both sides to get rid of that radical? So now we're going to have x over x plus 1 equals 36. Everybody with me so far? All right, I'm now going to cross multiply. So we have, it's not plus or minus because we're not taking the square root, we're squaring.
Was it x plus 1 or x minus 1?
Oh, was it minus 1 in the beginning?
Yeah.
Oh, that would have changed everything. Thank you, Layla. Okay, so now we're going to cross multiply, and I'm going to get x is equal to 36x minus 36. Subtract that 36x, and we're going to get negative 35x equals negative 36. So x will equal 36 over 35, positive. Okay, for this next side, red flag for me. What's the red flag?
It's a square root, but it's negative.
Yeah, it's a square root equaling a negative. All right, let's say you were just in the mode going through it, not a problem. You go and you square both sides. You're then going to get x over x minus 1 equals 1. You cross multiply, x minus 1 equals x. But then when you subtract the x's, you are going to get negative 1 is equal to 0. Is that a true statement? No. So obviously that whole side cancels out for us. That's not part of it. But because this was originally an equation with radicals and variables, right, we have to check. Because this was a radical equation with variables, we have to check our solution. So it's not going to be a fun check. We need to check x equals 36 over 35. So what does that mean? It means we're going to have 36 over 35 over 36 over 35 minus 1. Minus that whole thing raised to the half, and we need it to equal 6. I'm not writing anything in my parentheses because I want to simplify this all down. So we can do this the long way, where we create a common denominator and then subtract and then do keep, change, flip, and multiply. But does anybody else remember another way we can do this? No? Yeah, we could multiply, because it's complex, right? It's like fraction over fraction. You guys remember that? Yes.
Couldn't you just make the 1 a 35 and a 35?
I said that's the long way. We can absolutely do that. How many people would have done that? Made the 1 35 over 35 and then simplified from there? How many people would have treated it complex? Okay, we'll do it the longer way. We'll do it the longer way. So here we have 36 over 35. The first way is simplify that denominator. So we're going to have to make this 36 over 35 minus 35 over 35. So this is 36 over 35 over 1 over 35. Everybody still with me? All right, well, isn't this 36 over 35 divided by 1 over 35? Keep, change, flip. What happens? 35s cancel, so it's just 36. That was the longer way. All right, so now let's go back. This is going to be 36 minus 5 times 36 raised to the half equals 6. Well, isn't raising the half the same as taking the square root? What's the square root of 36? 6. So this is 5 times 6, not 60. So this is 36 minus 30. And does the check work? Yes, the check works. So our answer is x equals 36 over 35. Told you it was a pain. Okay, so that is the end of today's lesson. Homework